Good morning children, Sairam. Let's continue with chapter 3, playing with numbers. This is part 7 of the chapter. In this session, first we will solve a few more problems of exercise 3.3 which we could not complete in the previous session, and then we will move on to the next topic, that is common factors and multiples. So let's see what is the next problem. It is problem B of question 5 from exercise 3.3. Here is a number and we have a blank in this number, and we have to fill the blank with such a digit so that the number becomes divisible by 3. We have to fill it with the smallest digit and the greatest digit so that the number becomes divisible by 3. One problem of this kind we had solved in the previous session also. So let's see how we do this. For a number to be divisible by 3, we have to find the sum of its digits, and if the sum is divisible by 3, then the number will also be divisible by 3. Now let's find the sum of the digits that we have here. The digits are 4 and 7 and 6 and 5 and 2, and this sum is 24, isn't it? 4 plus 7 plus 6 plus 5 plus 2 is 24. And we know 24 is divisible by 3. 3 8 times is 24. So what will be the number? What will be the digit that we fill in the blank? What will be the smallest digit? It will be 0, isn't it? Because the sum of the numbers is the digits is divisible by 3. So if we fill the blank with 0, then it doesn't make any difference in the sum and the number will be divisible by 3. So the smallest digit that will be filled in the blank is 0. Now let's see what will be the greatest digit to be filled in this blank so that the number becomes divisible by 3. So what are the multiples of 3 after 24? The multiples of 3 after 24 are 27, 30, 33, 36 and many more we can get. But which will be the largest digit so that the number becomes divisible by 3, and we have to take only a single digit. So the multiples of 3 after 27 are 24 are 27, and 27 we get by adding 3 to 24. And the next multiple of 3 is 30, which we get by adding 6 to 24. Next multiple is 33, which we get by adding 9 to 24. If we go to the next multiple of 3, that is 36, we have to add 12 to 24, and we cannot take a 2-digit number here in the blank. We have to take a single digit. So which will be the largest digit to be filled in the blank? It will be 9. The largest digit will be 9, because next multiple if we take, we have to fill the blank with 12 and we cannot take a double digit. So the largest digit will be 9. So if you put 9 in the blank, the sum of the digits will become 33 and it is divisible by 3. So the largest digit or the greatest digit is 9, and what will the number become? It will become 4,76,592. Let's look at the next question, question number 6. Write a digit in the blank space of each of the following numbers so that the number formed is divisible by 11. So what is the rule of divisibility for a number to be divisible by 11? We have to find the sum of the digits in odd places, and then we have to find the sum of the digits in even places, and then we find the difference of the two sums. If the difference is 0, 11 or a multiple of 11, then the number will be divisible by 11. So here we have in A 92-389. So we have to fill the space, the blank, with such a digit so that the number becomes divisible by 11. So, for the convenience of solving this, let us take A in the blank. Let us consider A to be placed in the blank. So, let us find the sum of the digits in odd places. So, what are the odd places? They are the digits in the odd places are 9, 3 and 2, isn't it? And their sum becomes 9 plus 3 plus 2, 14. And what is the sum of the digits in even places? What are the even digits? The digits in even places, they are 8 and A and 9. So, 8 plus A plus 9, 8 plus A plus 9 becomes 17 plus A, because 8 plus 9 is 17 and 17 plus A. Their sum is 17 plus A. Now, let us find the difference of the two sums. 17 plus A minus 14 will be A plus 3, isn't it? So, 17 minus 14 becomes 3 and A plus 3 will be their difference. Now, for the number to be divisible by 11, the difference should either be 0, 11 or a multiple of 11. Let us consider the two cases where the difference is 0 or the difference is that means the difference A plus 3 should be 0 or it should be 11. In the first case, if we consider that A plus 3 should be 0, then A has to be taken as minus 3, because minus 3 plus 3 becomes 0 and we cannot take a negative digit in the blank. So, we rule out this possibility. We cannot take minus 3 as A. Let us consider the next situation. A plus 3 should be 11, that means the difference should be 11, and for the difference to be 11, for A plus 3 to be 11, we should take A as 8, because 8 plus 3 becomes 11, isn't it? And so, we will take the required digit as 8, because we cannot take a negative digit in the negative number in the blank space. So, we will consider the digit 8 in the blank and the number will become 9,28,389. Let us look at the next problem, B 8-9484. Again, for the convenience of solving the problem, let us place A in the blank and let us find the sum of the digits in the odd places. The sum of the digits in the odd places will be 4, 4 plus 4 plus A. That means 8 plus 8 plus A, and the sum of the digits in even places will be 8 and 9 and 8. So, 8 plus 9 plus 8 becomes 25. And what will be the difference? The difference will be 25 minus 8 plus A. And when we open the bracket, it becomes 25 minus 8 minus A. Because positive sign and negative sign, they will become a negative sign. So, it will become 25 minus 8 minus A. That means it will be 17 minus A. So, what is the difference between the two? It is 17 minus A. Now, let us consider this. For the number to be divisible, the difference should be either 0 or 11. In the first situation, if we consider 7 minus A to be 0, we have to take A as 17, because 17 minus 17 becomes 0. But we cannot take a double digit number here in the blank. So, we cannot take 17. And in the next situation, 7 minus A should be 11. The difference should be 11. And how it will be 11? if we take A as 6, then 17 minus 6 is 11. So, we should take A as 6, so that the difference, the 17 minus A becomes 11. So, the digit in the blank space cannot be 2-digit number. So, the required digit will be 6 and the number will become 8,69,484. So, in this way these kinds of problems we are going to solve. Now, let us move on to the next topic, that is common factors and common multiples. Now, let us quickly recollect what are the factors of number. The factors of a number are the numbers which divide the number exactly without leaving any remainder. And what are the multiples? If we multiply a number with another number, then the product is their multiple. For example, if we take 4 and if we multiply 4 and 5, we get 20. So, 20 is the multiple of 4 and 5, and 4 and 5 are the factors of 20. This we had learnt when we were doing factors and multiples. Now, let us see what are common factors and common multiples. Let us consider this example to understand this. Find the common factors of 12 and 18. So, what are the factors of 12? They are 1, 2, 3, 4, 6 and 12. All these numbers will divide 12 exactly without leaving any remainder. And now, what are the factors of 18? The factors of 18 are 1, 2, 3, 6, 9 and 18. These numbers will divide 18 exactly without leaving any remainder. Now, we can see that there are some numbers as the factors of 12 and 18 which are common in both, which are present in as the factors of 12 as well as 18. What are they? They are 1, 2, 3 and 6. So, these are the factors which can divide 12 exactly as well as 18. So, we call them common factors of 12 and 18. So, what are the common factors of 12 and 18? They are 1, 2, 3 and 6. Let us consider one more example, the common factors of 4, 12 and 16. These three numbers, what are the common factors of these numbers? First let us write the factors of these numbers. What are the factors of 4? They are 1, 2 and 4. And what are the factors of 12? They are 1, 2, 3, 4, 6 and 12. And what are the factors of 16? They are 1, 2, 4, 8 and 16. Now, we can see that the numbers 1, 2 and 4 are the factors of 4, 12 and 18. So, what are the common factors of 4, 12 and 16? They are 1, 2 and 4. Now, let us see how the common factors, finding common factors helps in the daily life situations. Here is a carpenter who has 3 logs of wood which are of different lengths. Now, he has to cut planks of equal length from each of the log. So, how will he do that? And he should do it in such a way that no wood is wasted. So, how is he going to do that? Let us see. First, we have to see what are the lengths of the logs of the wood. So, the lengths of the logs of wood are 30 feet, 18 feet and 12 feet. Now, let us consider this, how to cut the equal planks from each equal planks means length of the planks should be equal from each log in such a way that no wood is wasted. For this, we have to find the factors of the lengths of the logs, that is the factor of 30, the factors of 30 and factors of 18 and factors of 12. So, the factors of 30 are 1, 2, 3, 5, 6, 10, 15 and 30. And what are the factors of 18? They are 1, 2, 3, 6, 9 and 18. What are the factors of 12? They are 1, 2, 3, 4, 6 and 12. Now, we can see that there are factors which are common to all these three numbers. So, what are the common factors? They are 1, 2, 3 and 6. So, it means that if the carpenter cuts planks of length 1 feet or 2 feet or 3 feet or 6 feet from each of the log, then we can get equal pieces. He can get equal pieces without wasting any wood, because these factors will divide all the three numbers 30, 18 and 12 exactly. So, finding the common factors is useful in such real life situations. Now, co-prime numbers. What are co-prime numbers? Let's consider this example and understand this to understand what are co-prime numbers. Let's take two numbers 4 and 15. What are the factors of 4? The factors of 4 are 1, 2 and 4. And what are the factors of 15? The factors of 15 are 1, 3, 5 and 15. Do they have any common factors? Only one is the common factor between these two numbers, isn't it? Only one is the common factor of 4 and 15. So, such numbers which have only one as the common factor, these numbers are known as the co-prime numbers. We can find many pairs of such numbers which are co-prime. Now, let's understand the next topic, common multiples. What are common multiples? Now, we have learned in the previous sessions of the chapter that how to find the multiples of a number. Multiples of a numbers are nothing but the numbers found by the in the multiplication table by multiplying the number with more numbers, isn't it? So, the multiples of 4 will be 4, 8, 12, 16, 20, 24, 28, 32, 36 like that. And what will be the multiples of 6? The multiples of 6 will be 6, 12, 18, 24, 30, 36, 42, 48 and so on. We can find many more. But here we can see that there are multiples which are common to both of these numbers. They are multiples of 4 as well as of 6. What are they? They are 12. They are 12 and 24 and 36. These are the multiples which are common to both the numbers 4 and 6. So, we can say that common multiples of 4 and 6 are 12, 24, 36 and we can get many more as we go on multiplying the numbers with more numbers. Now, let's look at this example. Find the common multiples of 3, 5 and 6. So, how can we find the common multiples of 3, 5 and 6? For this, let's write the multiples of 3 first, then the multiples of 5 and the multiples of 6 and find out what are the common multiples. So, what are the multiples of 3? They are 3, 6, 9, 12, 15, 18 and so on. And multiples of 5? 5, 10, 15, 20, 25, 30 and so on. And multiples of 6? 6, 12, 18, 24, 30, 36, 42 and many more like this. So what are the common multiples of 3, 5 and 6? We can see that the common multiples are of these three numbers are 30. 30 are the multiples of 30 is the multiple of all the three numbers 3, 5 and 6, and again next one is 60. 60 is also a common multiple of these three numbers. We can find many more common multiples of these three numbers. So this is the way how we find the common multiples of numbers.